Today's lesson is lesson 25, a fraction as a percent. So we're going to skip example 1. I don't think it's going to help you solve any problems on here, so we're going to jump straight to example 2. So example 2, a survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. What did I just say? I read that and it didn't make sense to me, so I'm going to go back. 300 were unhappy, 700 were happy. Give a part to whole fraction comparing happy participants to the whole. So happy to, there's a ratio, whole. Then write a part to whole fraction of the unhappy participants to the whole. Okay, so whole means all of them together, right? So if we have 300 unhappy, that means, and we have 700 happy, how many do we have total? 1,000, that's right, 1,000 total. So this is our part, this is our total, or our whole. They're asking for a whole, that means total. All right, so as a fraction, happy customers, we have 700 out of a total 1,000. We need to make that into a percent. Now, what did I say yesterday? A million billion times. What is the percent always out of? That's right, 100% is always out of 100. So we need to turn our denominator into 100. All we have to do here, because we have zeros on top and bottom, cross out 1 0. If we cross it out on the bottom, we have to cross it out on top. That gives us our percent. Now we have a number out of 100, that's 70%. That makes sense? All right, let's do it again. Pay attention. So now it's unhappy. We have 300. We have a total of 1,000. Percent out of 1,000? No, Mrs. Haley, percent is always out of 100. So cross out the 0 on the bottom, cross out the 0 on the top. The percent is 30%. All right, it says use a model or create a model to justify your answer. So in order to do this, we're going to make kind of like, it's like a combination of a bunch of different models here. So we're going to put 10 spaces in it because percent is always out of 100, and we can simplify 100 down to 10. So we're going to do this, but we're going to almost make it look like a double number line at the same time. Okay, so on the top, we're going to put the percents, 10%, 20%, 30%, and so on, until we get to 100%. Okay, so if we do that on the top, the bottom is going to have the numbers that we're using. So we're going up to 1,000. So if we want to end at 1,000 right here, what numbers do we need in between? That's right. We need to count by hundreds. So 100, 200, 300, and so on. Okay, so now if I said 900 is what percent, you would say 90%. We can look at that and see it easily. Now we need to prove that 300 out of 1,000 is 30%. We can do that right here. Look, 300 out of 1,000 is 30%. Here we have 700, and it says 700 is 70%. Is that true? Yes, there's 770%. That was a model we just made to justify our answer. All right, exercise 1. Renita claims that a score of 80% means that she answered 4/5 of the problem correctly. She drew the following picture to support her claim. Is she correct? So we see a lot of boxes here, right? If you count them all out, you'll notice there are 20 in each box. So we go 20, 40, 60, 80, 100, which means it's at percent is out of 100, so she's good there. And if I do that again, 20, 40, 60, 80, how many rows are shaded here? 4, that's right. 4 out of 5 are shaded, and we said 20, 40, 60, 80. Is she correct? Yes, she is, right? Let's prove this. So here's 1 row, 2, 3, 4, and 5. Make sense? So, is she correct? Why or why not? Yes. Oops, said that already. Because 4 rows out of 5 are shaded, which is 80 out of 100 boxes. This equals 80%. How could you change Renita's picture to make it easier for Renita to see why she is correct or incorrect? You could do a lot of the different things. You could make the little model that we made up here. So a couple different ways to do that. All right, exercise 2. Use the diagram to answer the following questions. Okay, so they've made a diagram for us, so it looks like the one we made for example 2. Let's use it to answer questions. So it says 80% is what fraction of the whole quantity? Well, looking at this, do you see any fractions there? I don't. However, there are fractions hidden there, right? Because if this is 0% and this is 100%, that means that each of these is a part of the whole thing, right? So at 80%, we are at 4, but 4 out of how many? 5 total. So we're at 4 out of 5, which is 4/5, which is the same as 40 50ths, right? Multiplied by 10, which is the same as 80 out of 100. If we multiply by 2, which gives us 80%. Percent is always out of 100. All right, 1/5 is what percent of the whole quantity? Okay, so we've got to look back up here. Oh, I keep moving it, sorry. Look back up here. Where's the 1 out of 5? Right here, right? So 1/5% would be 20%. Now keep that in mind. This is 1/5, not just the number 1. That's going to be really important in a couple of questions. All right, I have to zoom out so we can see the question and the model. Next we have 50% is what fraction of the whole quantity? We go 0, 20, 40, 60, 80, 100. But this is just like a double number line, right? If this is 40 and 60, what can we put in the middle? Yeah, 50%. So if that's 50%, what's in the middle of 2 and 3? Yeah, 2.5. So we would write it 2.5 out of 5. What fraction? 2.5 out of 5. We can't leave a decimal over a fraction though, so we're going to multiply by 10 because this is tenths. It's the tenths place, which means we're going to multiply by 10. So 2.5 times 10, you can use your calculator, 2.5 times 10, hopefully you know this already, is 25. If we multiply that by 10, we need to multiply the bottom by 10, which gives us 50. Alright, 50% is what fraction of the whole quantity? It is 25 out of 50, or 2.5 out of 5, still means the same thing. Now the next one's where I said you've got to keep this in mind. So we have 1 is what percent of the whole quantity? It's not 1, this is 1/5, it's 1 whole. So how do we get 1 whole? 1 whole out of this model. That's right. It's got to be the whole thing, right? 1 whole would be 5 out of 5, which is 1 whole. So 1 whole is equal to 100%. Rewatch that if that didn't make sense to you. All right. Exercise 3. Maria completed 3/4 of her workday. Create a model that represents what percent of the workday Maria has completed. Zoom a little here. Alright, so if she's completed 3/4 of her workday, let's make a model. 3/4, that's easy, right? Been doing that since like 2nd grade. Okay, we have 0, 1, 2, 3, and 4. 3/4 of the workday. We know that if a percent is always out of 100, so that has to be 100, that has to be 0. What is in the middle of 0 and 100? That's right, 50. What's in between 0 and 50? Yep, 25. What's in between 50 and 100? That's right, 75. Okay, so we've just created a model. Let's show that 3/4 of the workday is complete. What percent of her workday is complete? 75%. That's right. Next question says, what percent does she have left to work? Well, if she's already worked 25%, how much is left? Oh, geez, I said that backwards. If she's already worked 75%, what does she have left? Only 25%, right? She has this much of her day left, which is 25%. How does your model prove your answer is correct? We can see that 1/4, right? 1 out of 4 boxes, 1/4 is left, which is equal to 25%. All right, exercise 4. Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? All right, now we're getting into eighths. Does 8 go into 100 evenly? No, it doesn't. So it gets a little more tricky. Still can do it though. 5 out of 8. You want to know the secret? Get a calculator. What percent? 5 divided 8 is 0.625. 0.625 thousandths. All right. Now, is percent out of 1,000? No, Mrs. Haley, it's out of 100. So in order to make this to the hundredths place, we can multiply. And when we do that, we move over our decimal. And it would give us 62.5. 62.5%. Did I totally confuse you right there? I'm going to repeat it one more time and then go back and watch it again if you don't get it. So when we divide, we get 0.625, but we need to make our decimal into hundredths. Right now it is not hundredths, right? This is the thousandths place way over here. So if we move the decimal over here, now we've gotten rid of that thousandths place. We have 62.5%. And we actually multiplied it by 100. 0.625 times 100 is 62.5. 1, 2, 1, 2, 2 zeros, 2 decimal places. It all matches up. Alright, and I just answered this right here. How can you use the decimal to get the percent? It's right there. Alright, exercise 5, you're just practicing a little bit with us. I want you to do this on your own and then come back and check your answers. Fill in the blanks. So 1/8, then put the decimal, then put the percent. Go ahead and do it and come back and check your answers. All right, welcome back. So we had 0.125. Because we took our handy dandy calculator, we divided 1 divided by 8 is 0.125. Now remember what I told you. Multiply by 100, percents out of 100, 12.5%. Okay, we have 0.35, which is 35 over 100, which is 35%. You can simplify this, divide by 7, just kidding, divide by 5, and you get 7 out of 20. Here they give us the percent, so 0.845, right? This time we move it backwards because we have the percent and we want to turn it into a decimal. Here we went to the right because we're turning it to a percent. This time we go backwards because we're going into a decimal. Okay, which is 845 over 1,000. Why, Mrs. Haley? Well, there's 3 decimal places, so it's over 1,000. It's going to equal 84.5 over 100. Remember, multiply, or divide in this case, divide by 10, and it'll give you 84.5. We always know that it's out of 100 though, so if we take off a 0 here, we have to move the decimal here. 84 divided 5, or 84.5. Alright, we have 0.325, so we have 325 over 1,000 equals, again same thing, drop the 0, move the decimal, 32.5 over 100, which is 32.5%. Okay, next we have 2 out of 25. How do we turn that into a decimal? Well, calculator, 2 divide 25. 0.08. We should have multiplied to get it out of 100, right? 2 times 4 is 8. Bob, best teacher ever said, grab a calculator. Okay, next we need to turn this into a percent. So we have 8%. All right. Exercise 6. Choose one of the rows from the conversion table in exercise 5 and use models to prove your answers. We're skipping that. All right. So lesson summary. Percent is always out of 100. Percent is always out of 100. Percent is always out of 100. Fractions, decimal, percents, they're all related. Percent always out of 100. Don't forget that. To change a fraction to a percentage, you can scale up or scale down, so 100 is the denominator. Again, out of 100, we always need to get it out of 100. When we have a fraction that doesn't go evenly into 100, just divide. Use the calculator. Divide. Okay, then we got to turn it into hundredths, right? Multiply by 100, it gives us our percent. Models like tape diagrams and number lines can also be used to model relationships, right? So we can use a tape diagram to model our relationship. All right, on the problem set, do number 1, use this grid for number 1. Number 2, tape diagram. So just like you see up here, tape diagram. Number 3, explain how they're related. So when you get these, how are they related? What decimal is also related to the fraction? And which diagram is most helpful to you? So there's no right or wrong answer. Just explain why it's easier for you. I'll give you a little hint. When we do 11/20ths out of a percent, let's think of this as pieces. So we've got 10, 20. So we're going to take this. That's one piece, and we're going to shade 11 of them. Then we have 1, 2. That's another 20th piece. Shade 11 of them. And keep doing that until you end up with all of them. And then it'll tell you your percentage, right? Because when you get to the end, however many are shaded are out of 100. So you'll be able to do your percent. All right. Tear it out, turn it in when you're done.